Hi everyone, I'm Aarini Panzade, and I'm from the Gatton Academy. My research is on the effects of TIMP1 levels, MMP1 levels, and healing times on the wound surface area. First, I'll give you a bit of an introduction on diabetic ulcers. Diabetic ulcers are a major health problem because they're the leading cause of non-traumatic amputations in many developing countries. In wound healing, there are two important factors, MMPs and TIMPs. MMPs are enzymes which degrade extracellular matrix proteins and therefore are a key element in the wound healing process. TIMPs, on the other hand, are an inhibitor of MMPs, meaning that all of the MMP's activity is inhibited by the TIMP. The objective of this research is to determine which of the interaction variables combinations had the most correlation with the wound surface area of diabetic ulcers. The original data that was provided had all the different MMPs and TIMPs recorded for each patient, including the wound surface area for each patient. However, from this original data, only some of the variables were used. The interaction terms that were used were MMP1 and TIMP1, MMP2 latent and MMP9 latent, and MMP1 and TIMP1, and many more. MMP2 and MMP9 are two of the types of MMPs that were used and were very important in diabetic ulcers because they're specifically involved in the initial inflammatory response and the remodeling of the extracellular matrix. To start my research, first I had to decide which of the interaction terms were appropriate with each other. Then, linear regression models were made for each of the combinations of interaction terms. How the linear regression models were made will be explained further on. Based on the linear regression models that were made, it was concluded which of the interaction terms had the most correlation with the wound surface area. This was similar to my research last year because this is exactly the method that I used, except in my research last year, I had only used one independent variable to create my linear regression model using Python, and I didn't have to use the Excel software to modify my data. To create a multivariable linear regression model for each of these interaction terms, first, the two interaction terms were multiplied using Excel software, and then the interaction terms were considered as the independent variable or the X variable in the model, and the wound surface area as the dependent variable or the Y variable. After they were multiplied using different libraries, linear regression formulas, and plots, a model was created for each of the interaction terms to compare it to the wound surface area. Then, using the coefficient and the error percentage, it was concluded which of the interaction terms had the most correlation on the wound surface area. These next three slides will show the graphs for the most common interaction terms. This is the first graph, which shows the interaction terms of MMP1 and TIMP1 compared to the wound surface area. This model had the greatest error percentage of 6%, with the correlation percentage of only 45. This is the second graph, which shows the interaction terms of MMP2 and MMP9 compared to the wound surface area. This model had an error of 2% and a correlation percentage of 75. This third graph shows the interaction terms of MMP2 latent and MMP9 latent compared to the wound surface area of the Y variable. This model had an error of 0.95% and a correlation percentage of 92. Since the third linear regression model, comparing the interaction terms of MMP2 latent and MMP9 latent to the wound surface area, had the least error and the greatest correlation coefficient, the MMP2 latent interacting with MMP9 latent had the most impact on the wound surface area of diabetic ulcers. This is true because this variable is in the latent form, meaning that even though they're underdeveloped, they have the most capability of being fully developed. This also makes sense biologically because they're involved in the remodeling of the extracellular matrix. In the future, I would love to continue this project in order to remove the outliers from the data to make the correlation percentage more accurate. And these are my references. Thank you. Any questions?